Are you ready?
Yes, I'm ready.
Okay. Yes, Diana, miss.
Hel- Hello, Miss. Okay, we can start our event. So, Roy, let's start, Roy.
A very warm good evening to all. I am much delighted to offer a hearty welcome to everyone gathered over here to listen to the topic When Nature Speaks Through Numbers. We are honored to have Reverend Father Verghese Tiruchara, our principal, Reverend Father Benny Nilera, our vice principal, Reverend Father Suman Josulnalil, our resource person for the day, and all my beloved teachers for this webinar. I would also like to thank you all for taking the time out of your heavy schedule and marking these hours with your presence. Let us begin the webinar by evoking the blessings of Lord Almighty. I welcome Aunt Stina to guide us in prayer.
He is my everything, He is my all. He is my everything, both great and small. He gave His life for me, made everything new. He is my everything, now how about you? Like honey in the rock, sweet honey in the rock. For He tastes like honey in the rock. See that the Lord is good, for He tastes like honey in the rock.
Thank you, Aunt Stina. I now invite Prashasti Gupta to render a few words of welcome.
A warm good afternoon to all. Thank you all for joining this webinar. Today, we have gathered here for a webinar on the topic When Nature Speaks Through Numbers, conducted by the Department of Mathematics. It gives me immense warmth and great pleasure to welcome you all in today's session. First, I would like to welcome our dear principal, Reverend Father Verghese Tiruchara, who brings up innovative ways to help students progress in their academics and extracurricular activities. Welcome, dear Father. I welcome Father Benny, Vice Principal of Don Bosco Senior Secondary School, Vadudala, to this webinar. Welcome, Father. I am delighted to welcome the chief guest of the day, Father Simon, who was an assistant professor in Department of Mathematics at Don Bosco College, Manuthi. BSc from Chris College, Irinjalakuda, he has done his post-graduation from National Institute of Technology, NIT, Calicut. He was also a teacher at Don Bosco Senior Secondary School, Vadudala from 2008 to 10. At present, he is the administrator of Mount Don Bosco, Padivale. We are very grateful to have you here with us today, Father. Welcome, Father. I welcome Ms. Anita, Head of Department of Mathematics, for organizing this webinar for our students. Welcome, Anita, Miss. A teacher is a candle who spends their whole life lightening up the lives of students. I take this opportunity to welcome all the teachers for their endless support. Welcome, dear teachers. Last but not least, I welcome you all, my dear friends. Let's together make this session into a successful one. Once again, welcome all.
Thank you, Prashasti, for those warm words. We are privileged to have Reverend Father Suman, who's our resource person for the day, in our midst. He was an assistant professor at the mathematics department at Don Bosco College, Manuthi. He is presently the administrator at Mount Don Bosco, Padivayal. I cordially welcome you, dear Father.
Thank you. Can I start?
Yes, Father.
Okay. I hope still Nayan sir is inside, right? Can you
Yes.
Can you do me a favor of I have logged in with another account, Fun Math. Can you add me to the panelists so that I can give the presentation from there and I'll speak with WebEx.
Yes, Father, you are added.
Okay, thank you. I think now the presentation is clear to all of you. Okay.
Yes, Father.
Okay. So, a very good afternoon to one and all. And at the very outset, my special thanks to Father Verghese, the principal of Don Bosco Senior Secondary School, Vadadila, for this opportunity. And also to Anita Miss, who was once upon a time a colleague of mine and head of the department, who is always interested in giving new things to the students. So it is so nice of you to organize this webinar, not because I am the speaker, but mainly because of the that interest that you show in giving new topics, new knowledge to the students. Many a times we have this kind of webinars, seminars, and all in a college level only. Many people don't organize such things in schools. But then our Don Bosco School, Vadadala, has been showing a very good example, and I appreciate that. Now, today we are going to listen to a topic called When Nature Speaks Through Numbers. So what exactly are we going to do? See, one thing that many of us complain is this. Many a times we study a lot of things in mathematics, but then we often wonder why on earth we study all this. For example, we study trigonometry, maybe sine theta, cos theta, tan theta, or the relations between the trigonometric functions. And we wonder, where am I going to use all this? So that is what leads us to the topic of the day, which is when nature speaks through numbers. The subject called mathematics came into existence not for fun alone. It was a way of interpreting what we see around us. So the initial mathematicians, their intention was not anything to do mathematics for mathematics' sake. No. What they intended was to look around the nature, try to understand more about the things, the objects, the phenomena, the processes that they saw around them in the nature. And today, what we are going to deal with mainly is a few things like, first of all, today's the key topic is the Fibonacci sequence, and initially we will learn what sequences are, then the famous Fibonacci sequence, and we will try to identify a few of the Fibonacci numbers that we see around in nature. This is, we can take only one area of mathematics in and around the nature because our time is limited. So we will take Fibonacci sequence and the golden ratio and how they are found in the nature around us. So that is what we are trying to do. Now, okay, now you have in front of your screen a short number sequence. We are all familiar with this very simple exercise where we try to identify the number which completes this sequence. Okay, I am giving you a small challenge. Why don't you all try to identify the missing number and complete this sequence? You have a few seconds for you to work, but then you have to work fast. I'm sure all the students are trying. And if you get the answer, you are free to put it in the comment box. Are we getting any answers? I'm sorry. Yes, we are back to the screen. Anybody who could identify the last number of this sequence? Are we getting any answers in the chat box? Yes, somebody says 766. I'm sorry, that is not the answer. Try. Our first attempt should be, yes, somebody has come with a correct answer. Serene Rose. What is the correct answer? The correct answer is this. First of all, let us see what is the relation between those numbers. The first number was 2 and the second number is 5. So what is the relation? When we take any two numbers in this sequence, the second number is one more than the square of the previous number, or you multiply the previous number by itself and add 1 to it and you get the second number. Now let us try out another one. See, we have the previous one was a number sequence. Here we have a pattern sequence. Look carefully and try to identify what is the number that is missing in the central figure that you see. You're free to identify the number and then put it in the chat box. I'm sure the children of Don Bosco School, Vadadala, are all very smart and you will be able to do it very fast. Srihari, 10. Yes, I think Srihari has come up with the correct answer. The correct answer is 10. Why? Because if you look at those numbers there, you can see you take 2, 5, and 3. 2 plus 3 is put in the center box in the same place where 2 and 3 appears. You consider 4 and 1. 4 plus 1, 5 is given in the central pentagon, exactly in the same place where 4 and 1 comes. So that is the relation that we have there. Okay, so the answer was 10. Now, that brings us to the topic of the day. What is the purpose of mathematics? So what is the purpose of mathematics? As I was saying in the introduction, mathematics is not about numbers, equations, computations, or algorithms. It is about understanding the world around us. We are trying to understand the phenomena around around us, the phenomena that we find in the nature, by interpreting them through numbers. So that is what the purpose of mathematics is. So okay, see, we have several different kinds of patterns that we have around. See, initially we have a pattern 11, 17, 23, 29, 35, 41, 47, 53, and it goes on. What is that pattern? That is a pattern that we find, a number pattern that we find by adding 6 to the previous number. So you add a 6 to 11 and you get 17, and likewise it proceeds. Underneath there is yet another different pattern, that is 2, 4, 6, 8, 10, 12. A very simple pattern where the pattern is that each second number is obtained by adding 2 to the previous number. So that is about number patterns that we find. Now, it is not only number patterns that we have other kinds of patterns. Okay, we have geometrical patterns. You look at the first set of numbers, this is a geometrical pattern as well as a numerical pattern. Let us see. See, the first set that you find, that those dots that you find arranged as triangles, is called a set of numbers called triangular numbers. Number of dots that can be arranged as triangles. So we have triangular numbers there. So the first triangular number is 1. Second triangular number is 3. The third one you can count by yourself, and the fourth one we have. Those are the triangular numbers. In the next set of patterns below, what is given as squares, we have square number patterns. The first number in that square number patterns is 1, and the second one is 4. The third one is 3 square, which is 9. The fourth one is 4 square, which is 16. The fifth one is 5 squares, which is 25, and it goes on. So these are two different kinds of patterns. The first one was a number pattern. Now we have a different kind of pattern called a geometrical pattern, where we see geometrical shapes. Now, okay, so that brings us to the topic sequences. Sequences are certain patterns. Why do we need sequences? Of course, sequences, we create this concept called sequences mainly to interpret what we see around us, mainly to interpret the patterns that we see around us. So let us try to understand this concept. Sequences. What are sequences? A sequence is an arrangement of any objects or a set of numbers in a particular order followed by some rule. Okay, that shows that there are two things that are necessary. That is, there should be an order and there should be some rule which is governing that order. That is, if you take the sequence, let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it goes on like that. That sequence, the order is the first member is 1, the second member is 2, the third member is 3. Now, to understand it better, let us take another sequence, maybe 2, 4, 6, 8, 10. This is the sequence. In that, there is an order of those numbers. For example, the first number is 2. The second number is 4. The third member of that sequence is 6. The fourth member of that sequence is 8. The fifth member of that sequence is 10. So, in any sequence for that matter, there is an order. Now, is it only order that is in the sequence? No, there is also some rule which is governing this order. Now, you cannot take a number so randomly like that? What is the order in the last sequence that we mentioned? That is, each number is obtained by adding 2 to the previous number. So there are 2 things in a sequence. That is, first one is an order, and the second one is some rule which is governing this sequence. Now, okay, 2 more terminologies we will learn. That is length of a sequence. Okay, what is the length of a sequence? The number of terms in a sequence is called the length of the sequence. Okay, of course, I don't think you have started studying sequences. That is why we are introducing a few new terms, things which you will study later on, maybe when you start studying the higher secondary mathematics, probably, or at a college level, whatever it is. Let us learn a very simple terminology, which is length of a sequence. The number of terms in a sequence is called the length of the sequence. You look at the sequence, first one, A, 1, 2, 3, 4, 5. That's all. What is the length of that sequence? The length of that sequence is 5. Now look at the second sequence. 5. Next number is obtained by multiplying 5 by 5, which is 25. The next number is obtained by multiplying 25 by 5, which is 125, 625, and it goes on. What is the length of this sequence? This is a sequence of infinite length, because you take any number, multiply it with 5, and you will get the next number in that sequence. So this is an infinite sequence. Okay, so we have 2 kinds of sequences: finite sequences, which have only a finite number of elements or a finite length, and infinite sequences which has got infinite number of. Okay, now let me give you a very simple story. There was this famous Italian mathematician by name Leonardo Fibonacci. Okay, it is not read as Fibonacci, it is read as Fibonacci. So there is this famous mathematician Leonardo Fibonacci. So one day he posed an imaginary question, a very interesting question, which gave rise to an entire search path in the field of mathematics, which is called Fibonacci numbers. Now, what was the question? Let us suppose that a pair of rabbits, I'm sorry, there is a slide. Can you hear me?
Yes, Father.
Okay, that was an accidental thing. I am not able to return to the. Anyway, doesn't matter. Okay, there is a this imaginary question that he posed. If a pair of rabbits is placed in an enclosed area, you take one male rabbit and a female rabbit and put it in an enclosed area. How many rabbits will be born there? Okay, then there are a few conditions. If we assume that every month a pair of rabbits produce another pair of rabbits, and that rabbits begin to bear young 2 months after their birth. Okay, so this was the question. So there are 2 conditions. The first condition is that rabbits start producing the young ones only 2 months after their birth. Okay, the second condition is that every month rabbits will produce a set of young ones each. So he was wondering how many pair of rabbits will be there at the end of each month. That was the question. I hope you all have understood the question. Why don't we just think about it? Okay, there is a pair of rabbits placed in an enclosed area. Okay, the question is how many rabbits will be born after each month. Okay, but we have 2 conditions. The first one is that a pair of rabbits produces another pair only once in every month. Okay, every month they will be able to produce another new pair, and also a newly born rabbit, a bunny, will be able to get another pair. They will be able to reproduce only 2 months after their birth. Okay, why don't we just think about this question for a while. And Fibonacci found that outcome. This was his finding. So let us evaluate this solution. Okay, here I have given the solution till the month, till the 5th month. Okay, let us look at month 0. Okay, month 0, they won't be able to produce because we are putting a new pair of rabbits. So the initial pair will be there, no more pair, and it goes to month 1. Then also it will be only one pair. Why? Because they will be able to start producing rabbits only from the 2nd month onwards. So when we come to month 2, what do we have? We have another new set of rabbits which is born. So in month 2, we have how many pairs of rabbit? We have 2 pairs. Okay, it goes to month 3. Okay, those black 2 rabbits are there. They will produce another pair, which is red one, and the previous violet one. What happened to them? They are not yet ready to produce because they need 2 months, right? So in month 3, how many pairs will we have? We will have those red rabbits, those black rabbits, and those violet rabbits. Of course, it doesn't indicate the color of the rabbit. Just to differentiate between those rabbits, I've given it in different colors. Now, let us look at month 4. What happens? So we have those black rabbits from the beginning onwards. They are there. Okay, let them be there. Then they had produced one set of red rabbits and another set of violet rabbits. Okay, those are also there. But now you look at the violet rabbits, they have reached to 2 months, right? So they will be able to produce a new pair of rabbits. So we have a green pair of rabbits there. Similarly, with the black pair of rabbits, they produce yet another pair, which is the blue one. And red ones, are they capable of producing now? No, not yet, because they have not reached completed 2 months. So at the end of 4 months, we have how many rabbits, how many pairs of rabbits there? We have 5 pairs there. Let us look at the 5th month once again. So we have the initial black pair of rabbits, the red pair which the black pair produced, and also the violet pair which is the offsprings of the black pair, and also the black pair also had produced a blue one. Those are also there. But now all are capable of reproducing again. The violet one is capable of reproducing. Okay. The black one is capable of reproducing, and the red one is capable of reproducing. So finally, how many pairs of rabbits will we have? We will have 8 pairs of rabbits in the end of the 5th month. Okay. Now you look at those number of pairs that are written there. There is the first 0th month, it was 1. The first month, again that 1 remains. Second month, what happens? The second month, there were 2 pairs. How did we obtain? This is 1 plus 1, which is 2. And in the 3rd month, you look at the number of pairs. How did we obtain that number? 2 plus 1. That is, those previous 2 numbers are added to get the next number. This series continues. This sequence continues. So, thus we get a Fibonacci sequence. What is Fibonacci sequence? It's a sequence where any number is obtained by adding the previous 2 numbers. For example, the first number is 1, the second number is 1. Then what will be the third number? It will be 2. What will be the fourth number? 2 plus 1, which is 3. What will be the fifth number? 2 plus 3, which is 5. what will be the sixth number, which is 5 plus 3, which is 8, and it goes on. Okay, so Fibonacci, Leonardo Fibonacci identified that this is the pattern in which rabbits were multiplying. So thus he formed this into a sequence of numbers. So what is the peculiarity of this sequence? In Fibonacci sequence, each number in the sequence is obtained by adding the two numbers which precede it. So we have the first number 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, and 2 plus 3, we get the next number 5, 3 plus 5, we get the next number 8, 5 plus 8, we get the next number 13, 8 plus 13, we get the next number 21, and 13 plus 21, we get 34, and this sequence proceeds. So this is the sequence which Fibonacci identified, Leonardo Fibonacci. Now, this sequence is not only applicable in the case of the multiplication of rabbits. So before we go into that, we'll just try to identify who is Leonardo Fibonacci. He is a famous mathematician, Italian mathematician, okay, often called by Fibonacci or Leonardo Fibonacci. Okay, sometimes he is also known as Leonardo of Pisa or Fibonacci of Pisa. He lived probably from 1170 to 1240 or 250. His death, we are not able to identify it historically, but probably he died between the years 1240 and 50. Okay. Now, what is his main contribution? His main contribution is he started applying the Hindu-Arabic numeral system in the West. Now, what is so special about it? Until then, they were using the Roman system in Europe and in the West. We know how to write the Roman system of numbers. We name our classrooms probably. We put class 10, we put an X there, or class 9, we write it by preceding that X by a 1 or a straight bar, and like that we write Roman numerals. That was a system which was in existence till the time of Leonardo Fibonacci. Of course, there were some corners who were using where people were using the Hindu-Arabic numeral system, the numbers that we write now, 0, 1, 2, 3, and all, just as we write. Okay, our numerical system. But until then, the popular system was the Roman system in Europe. But then it is Leonardo Fibonacci who popularized the Hindu-Arabic numeral system in the West. Now, another very important contribution of Fibonacci is that he authored the famous book called Liber Abaci. Liber Abaci. So it's a very famous book by Leonardo Fibonacci. He wrote other books also, but the most famous among them is Liber Abaci. Now, there are many mathematical concepts named after him because of its connection to the Fibonacci numbers. So there are many things named after Leonardo Fibonacci. Leonardo Fibonacci because of its connection to the Fibonacci sequence. Now, okay. Now let us, for a fun, let us, okay, we can remember the numbers of the Fibonacci sequence. Okay, we are going to draw squares, okay, with sides from the Fibonacci sequence. The first digit and the first member of the Fibonacci sequence is 1, and we have a square 1 with 1 as the length of its side. Okay, then the second number is also 1, so we have another 1 there. What is the third number? 1 plus 1, 2 is the third number. So we have marked a square with the area 2, which means with the sides 2. And we have marked another one with side 3. because 2 plus 1 is 3. 3 is the next number in the Fibonacci sequence. Remember the next number in the Fibonacci sequence? 3 plus 2, okay, 5. So we mark a square which has got 5 units on one side. Okay, so we have a square with 5 units length on one side. Then what is the next number in the Fibonacci sequence? 5 plus 3, which is 8. Sorry, if you can hear the bell here, we have the bell for the brothers. Satisfied. Sorry. Okay. The next number is 5 plus 3, which is 8, and we have drawn a square with side 8 units. Next number is 5 plus 8, 13, and we have another square with 13 units as the length of a side. The next number is 21. Now, why on earth do we go drawing like this? See, don't you see that this is a perfect fit? If you randomly take any numbers and start drawing the squares, we won't be able to arrange them, adjust them, a perfect fit like this. You look at the next number. The next number also you can adjust that square, that which is 21 plus 13, which will be a square to this entire length. Okay, you can see that, right? Okay, so what is so special about it? Now, this brings a lot of stability in nature, and that is one reason we find Fibonacci numbers very often in the nature. Now, you see, we have a kind of spiral structure which is being formed by these squares. See, from the inside, in a very orderly manner, this spiral is made. Now, you might wonder, why do we need to know all these things? These are all creations of Fibonacci. Now, what is so special about it? Now, do you start noticing something special? We have this particular shell which follows exactly the same spiral structure of the Fibonacci sequence. If you count the number of units in each of those spirals, you'll find that it is equivalent to the Fibonacci numbers. So each member will be the different members of the Fibonacci sequence. You look at this. This is the central portion of a sunflower. You look at, you start at the central point and slowly observe where each row goes. Okay, that each row in that sunflower, it takes a turn like a Fibonacci sequence number, and it turns in spirals like this. Now, is it over with that? Not yet. There are other things in the nature which would follow the same structure. Okay, this is an artificial structure. See, we have a spiral ladder following the same structure, just like a Fibonacci sequence. Okay, or else the next one. See this particular plant here. Look at the structure of those leaves. Those leaves are also following the same kind of Fibonacci spirals. Taking in each turn the number of spirals that if you count, it will be the Fibonacci numbers. Okay, so we have like this several places where Fibonacci sequence appears in the nature. See, this is the picture of a coral following the same structure, the spiral structure that we find among the Fibonacci numbers. The spiral structures formed in the squares that follow the Fibonacci numbers. Okay. Now, like this, we have several places. Now, what is it? This is the body of a man. It's actually a very famous painting by a famous painter, because he was also a mathematician by name Da Vinci, Leonardo da Vinci. Okay, and he drew this painting. Why? This painting also follows the Fibonacci spirals. Don't you see that? Now, I'm sorry, there are some notifications coming. Don't worry about that. Now, see the famous temple of Parthenon in Greek. They also have followed this Fibonacci spirals. Why? Now, don't we see that this kind of spirals can be fit into many things that we find around us in the nature? Maybe to the structure of leaves on a plant, maybe to the structure of corals, maybe to a very artificially made temple like the temple of Parthenon. It's a very famous Greek temple which was destroyed many centuries back, and the same structure that can be found in a spiral ladder, the same structure can be found in the arrangement of leaves of a plant, or in the corals, and in several, okay, even in the structure of the pineapple, we can find the same structure. Do you think it is very strange? Fibonacci sequence was a sequence which is supposed to be a numerical creation, something which is simply a sequence of numbers. But it is not only a sequence of numbers, it appears again and again in the nature. But that should tell us something. The Fibonacci sequence has got some connection to the nature itself, some connection to beauty. So, see, you have the face of somebody very familiar. It is Donald Trump. Don't you see there is a way of drawing the Fibonacci spirals for the face of Donald Trump also? The natural inference is this. Fibonacci sequence has got, I'm sorry. Fibonacci sequence has got some connection to the beauty that we find around us in the nature. It has got some connection to many things beautiful that we find in the nature. So this is a sequence that we find in the nature. Okay, so that is the speciality of this sequence. Fibonacci sequence is found in the nature, especially it marks beauty. See, look at this very famous painting by Leonardo da Vinci. You know this painting, okay? I'm sure. The Mona Lisa. See, look at that Mona Lisa. What creates the beauty in this painting? It is the centrality of that spiral in this figure. Now, what would happen if this spirality is not there in this figure? Okay, we will take another example maybe at another time in this presentation. So, whatever is really beautiful, really pleasing to the eyes, just got some connection to the Fibonacci numbers, to the Fibonacci spirals. Now, they say, okay, Fibonacci numbers and photography, entirely two different streams of things. But they say if you are able to frame your photos when you take a picture, if you are able to frame your photos in such a way that these Fibonacci spirals are satisfied, or else your frame is in such a way that we can fit in these Fibonacci spirals in your frame, they say your photos will be much more attractive than a usual photo that is taken. Don't you see a very strange thing? Something which is of numbers, something which is of mathematics, can be connected to art. See, this a particular form of art. This can be connected probably to all the architecture that we find around. We saw the temple, Parthenon temple of Greece. It can be connected to many of the things that we find around us in the nature. Of course, it is very strange, but it is a truth. Fibonacci numbers occur very often in different forms in the nature. Okay, now let us go ahead. I'm sure you are all a bit tired. You have a small puzzle for you to answer, just to wake you up all in case somebody has slept off or somebody has turned inactive. Look at this figure and find out, this is the weight, okay? What is the weight of each animal? That is what you need to find out. You need to find out the weight of the bear, of the fox, and the rabbit, okay, or the bunny. Okay, all of you start working out. It's a very simple one, especially for 10 standard students, 9 standard students, 8 standard students. It must be very simple to work out. Okay, bear 60, Ryan Chetisheri says bear 60. Okay, rabbit 10, Annamol says rabbit 10. Okay, what about the fox? Okay, fox 20. Okay, many of you have found the answer. It's a very simple one. Okay, so this is the answer. If two bears are weighing 120 kg, that means one bear is 60. So the weight of one bear is 60 kg. A bear and a rabbit are 70 kg, and we know the weight of the bear is 60 kg. That means the weight of the rabbit is 10 kg. Now we know the weight of two animals in the third equation, and then we can calculate the weight of the fox, which is 20 kg. Okay, now we go to a related topic, a topic which is very much inherent in the Fibonacci numbers, the topic of the golden ratio. Okay, it is also called the divine ratio. This is a ratio which comes about from the Fibonacci sequence. Okay, what is a golden ratio? Golden ratio is known as also known as golden section or golden mean or the divine proportion or the divine ratio in mathematics. Why divine? Because it is found in the nature. As I said, when the creator was formulating the various things in our nature, he used the golden ratio, the Fibonacci sequence. So this is called divine proportion also. So what is it? It is a particular number. And what is the peculiarity of that number? That number is an irrational number. What is that number? It can be almost said as 1 plus root 5 divided by 2. 1 plus root 5 divided by 2. So which is about 1.618. Of course, I already said that this is an irrational number. What does it mean that a number is irrational? Means if you write it as decimal places, it doesn't end at all. So it just proceeds 1.618, etc., etc. It proceeds. It doesn't end because it's not a rational number. So, so it is approximately equal to 1.618. That is that golden ratio. Okay, and it is represented often by the Greek letter phi. Okay, phi. That is that Greek letter that you find in the presentation. And how do we obtain this? Actually, this golden ratio was obtained especially from some other areas of mathematics. But why it is related to Fibonacci sequence? Because this golden ratio can be obtained from Fibonacci sequence. You start dividing each number of the Fibonacci sequence by the previous number. The first one is 2 divided by 1, it is 2. Second one is 3 divided by 2, which is the previous number, then you get around 1.5. Third one is 5 by 3, and it proceeds, right? One thing that we find is that as we proceed ahead in the Fibonacci sequence, you go higher and higher in the Fibonacci sequence, take each number and divide it with the previous number, then we find that the result comes slowly closer to this value called 1.618. Or in other terms, as we proceed ahead in the Fibonacci sequence, when we take the ratio of one number and the previous number, it is approximately equal to the Fibonacci golden ratio. Now, look here. On the left side, among the ratio, what you find are all the Fibonacci numbers. See, the first one, 1 by 1 is 1, 2 by 1 is 2. It doesn't come closer to 1.618. Okay, look at the third one, 3 by 2. Then it is 1.5. It is coming closer to 1.618. Look at the next ratio, 5 by 3. Where does it come? It comes again closer to 1.618. So it is 1.66667. Okay, or else you take the next one, 8 by 5, again coming, approaching 1.618 from the other side, 13 by 8, the result is 1.62500. 21 by 13, 1.61538. See, it is coming closer to the golden ratio. 34 by 21, 1.61905. 55 by 34, 1.61765. 89 by 55, 1.61818. You go ahead in this Fibonacci sequence and continue this operation, you will find that this comes very close approximation. There comes a very close approximation of the golden ratio or the number 5. Okay, so this 5, okay, I have no much of time, that is why. Otherwise, this 5 actually comes to the picture of mathematics from an entirely different section of mathematics. But see, we are relating two things: a sequence which was formulated by Leonardo Fibonacci and the concept of golden ratio, which comes entirely from another stream of mathematics. See, they are slowly coming closer to each other. Now, another a little puzzle for you, just for you to brush up your brain. Come on. 9 plus 5 is equal to 2. How can this be? This is correct also. Can anybody tell me a situation when 9 plus 5 is 2? Come on, smoke your brain, and in case you can find the answer, put it in the chat box. Nine plus 5 becoming 2. Is that possible? And of course, the puzzle says it is correct. How can it be correct? A small challenge thrown to the very smart boys and girls of Don Bosco Vadadala. Come on, smoke your brain. Yes, exactly. Johan John Anand. Congratulations, Johan. It is correct. He answered it that it can be true in a clock. You add 5 hours to 9 o'clock, 9 a.m. plus 5 hours, you will get what? 2 p.m. Okay, the answer is correct. And congratulations, Johan. You are quite sharp. See, when it is 9 a.m., add 5 hours to it, and you will get 2 p.m. So 9 plus 5 is 2. So this is the occasion when it is correct. Okay, that was a simple question. So let's see what we have found so far. We are discussing about the Fibonacci numbers, Fibonacci sequence, wherein we find a sequence of numbers where each number is obtained by adding the previous two numbers, and the golden ratio, which is 5, a value with a value 1.618, etc., etc. It is a irrational number, and we found how they are related, these two things. Now, why did we say that golden ratio is found in is related to Fibonacci numbers? We said Fibonacci numbers are very much important as far as beauty, pleasing, whatever is pleasing to the eyes. It has got some connection somehow, very interestingly, to the sorry. I'm really sorry for this interruption. It was quite accidental. Okay. See, This is a very famous film actress. Okay, of course, I'm sure you will know the name. I think it is Angelina Jolie. So see the face. What is shown here is a golden ratio analysis of her face. The ratio between the larger lines and the smaller lines. Of course, I have no facility to point it out. That is a problem. Okay, I'm sure you will read through it later on, maybe when you get time, where the figures will point to you the ratio between the larger lines and the smaller lines should come around 1.618, and that adds beauty to the figure. What would have happened if the golden ratio, the Fibonacci spirals were not followed? We have the phase of, isn't that Arnold? Yes, that is Arnold. See, what would have happened if this particular spiraling was not there in the phase of Arnold? You can look at the second figure. It would have looked something like that. See, another set of film actors, of course, people whom we admire. So even on their faces, see this golden ratio. So this somehow this golden ratio and the Fibonacci numbers have got some connection with beauty, whatever is pleasing to the eyes. So what I was trying to arrive at is this. We have a purely numerical thing called a sequence, which anybody can form just by adding two numbers. You get the next number. But that is being related not only to numbers alone, but it is being related to beauty that we find around in the nature, to whatever is pleasing to the eyes. This Fibonacci sequence has got great applications in photography, in arts. Don't you think it is strange? Something of a numerical thing is related to photography, and something of a nature of an art, or else it has got a relation to painting. I showed you the picture of um, Mona Lisa already, or else it has got a relation to the arrangement of leaves on a plant. It has got a relation to probably the arrangement of corals, okay, the circles of a coral, the arrangement of shells of various sea creatures and things like that. See, we are taking numerical thing, relating it to the nature, relating it to beauty. So that is why this Fibonacci sequence is considered as something very important as far as beauty, as far as whatever is pleasing to the eye is concerned. I'm sure you will all read up more about Fibonacci numbers, Fibonacci spirals, Fibonacci sequence, and the golden ratio, how the golden ratio is found in the nature. There may be a few of you who are interested in photography, I'm sure. I'm inviting you all later on to read up a little bit about the connection of golden ratio and the photography, the connection of the Fibonacci spirals and the photography. So this would be a very good, maybe a small exercise for all of you, a small little homework. Probably those who are got interest in mathematics can do this. Read up a little bit about photography and the golden ratio, or else the Fibonacci sequence, the occurrence of Fibonacci numbers in the nature, the occurrence of Fibonacci spirals in whatever is beautiful in the nature. So this is, dear friends, mathematics has got immense applications as far as understanding the universe around us is. Mathematics has got a great role to play in interpreting the nature around us. So this is just a simple area. The Fibonacci sequence, the golden ratio, is a simple area of application of mathematics in interpreting, in trying to understand what we find around us in the nature. Now, why on earth did I choose this topic? The reason is this. Many a times, as I said in the introduction, we wonder, why do we study this kind of concepts in mathematics? Um, Often they don't seem useful to us. We might think, why do we need sine theta? Why do we need cos theta? Or else, why do we need to uh, study geometry? Or why do we need to study sets and relations and functions and all these concepts in mathematics? The answer is very simple. Anything of mathematics has got an application in the nature, in the phenomena that we find around, in whatever we do, in whatever we invent. Mathematics is not a subject which is born for the sake of that subject. For this is not for simply for teaching in um, the schools and colleges. The aim of mathematics is not to teach you a few things, something just for to burden you or to simply to boost your memory tricks and all. No, the aim of mathematics is very clear. It is understanding whatever we find in and around us. It is to understand whatever what we find around. Do you know that the heartbeat of a person can be modeled as a function? We can model the heartbeat of a person as a function. The structure of a heart, the shape of heart can be traced as a function. All these things will enable us in trying to understand the heart better, in trying to attend more to the medical needs, especially in the area of cardio research. Or else, let us take another example, the trigonometry that we study. Okay, many a times for many people, trigonometry is an enemy because we need to study a lot of relations by heart. We need to learn them by heart. So it is an enemy. Do you know that the very way in which the signal is transmitted in our mobile phones, in the internet, has got a very strong relation to sine theta and cos theta and the trigonometric functions? Actually we transmit them in the structure of a trigonometric function only, various trigonometric functions. Or as let's take another area. Uh, do you know the various operations that we have, that we study, has got very far-reaching consequences as far as our space research is concerned? Did you know that whatever we study in the school by way of mathematics has got a very strong connection to the advancements that we make in the physical world, the various inventions that we have? It has got a very strong connection to the structure in which, let us say, not the structure, the pattern in which a pandemic is proceeding. Now we study a very important area of research in mathematics currently is the study of pandemics, the very study of how diseases spread. What is the speed? Can we predict? See, now we see that, see, sometimes our chief minister is talking in the press conferences with the advice of his um, advises that it is possible that the third wave may come in the month of, let us say, August. How do they say that? This is by purely by applying mathematics to it. We are studying the pattern in which this particular pandemic is proceeding, and then we are trying to project it to the future. The prediction of rain, how do we predict it? It has got a very strong relation to various mathematical structures, especially a lot of statistics is used in predicting rain. Or else it is not only about they look at the clouds. See, clouds sometimes will come only next week. Then without knowing about the cloud distribution next week, how are we able to predict the rain which might come next week? It has got very strong connections to mathematics. So my final word of request to you students is this. See, don't get discouraged with mathematics. Mathematics is a very easy, a very interesting subject the moment you start enjoying it. The moment you start enjoying it, it can become very interesting for you. Uh, Probably I did not enjoy mathematics at an early age of my life. But there was a time when I fell in love with mathematics, and it was quite interesting, I tell you. And if you study mathematics with interest, and if we are able to go a little beyond your textbooks and find out what each concept that you study in the class is used for in the real world, mathematics will become doubly interesting for you. So study mathematics well, and be good mathematicians for the future. And all the best to all of you. And I found that you are all quite prompt in answering the questions, the puzzles that we had. And I'm sure the children of Don Bosco Vadadala are quite smart. And all the best to all of you. Once again, a word of thanks to the panel of teachers who are instrumental in inviting me for this little sharing session. And also, sorry, to all the members of the staff of Don Bosco School, Vadadala, who were instrumental in helping me with this presentation. And thanks a lot to all of you. If you have any questions, since you are not able to ask me directly, since is created as an event, you are free to put it across to me in my mathematics. Of course, I have a very personal mathematics site of mine, and the Gmail ID of that one is there. Fun Math Express. You are free to send your questions. If it is something that I can answer, I will be really happy to assist you. And thanks a lot to one and all, and thank you very much. Now over to the faculty.
Okay, thank you, Father Suman. The session was really interesting and informative, and we look forward to many more sessions like this from you, Father, in this academic year. And for the students, if you have any queries, you can put it in the chat box now. Have you received any questions, Father, from the students?
Are tsunami waves? I'm sorry, I lost it. Do I take it? Somebody had sent a question. I'm sorry, I missed it. Will it be